evening to everyone watching this video. My name is Ghana Lanika and I'm here to discuss my Uniswap Hook Incubator capstone project called Janus or Susanoo as I like to call it. So Susanoo is a Uniswap hook that gives traders the extra functionality of fully private and trustless limit orders on chain using the power of fully homomorphic encryptions powered by Phoenix protocol. So what are limit orders? Limit orders are trades we set to execute at a later point in price or time. So they are actually quite common in centralized finance, where users create order to buy or sell a particular stock at a price of interest. So why haven't we been able to replicate them on chain? So due to the public nature of the blockchain, implementing limit orders on chain makes your trades more vulnerable to our worst enemies. I know our worst enemy is MEV bots. Putting limit orders on chain is like a shiny light screaming, oh, okay, I want to sell this token at this particular price. MEV bots monitor that price of interest as it would be public for everyone to see. So what if we could hide our trade alpha in a cryptographic black box? What does this mean? In a sense, what if we could have an order that was totally private until the moment it was executed? So this is what Susanoo brings to the table. So when an order is placed, Susanoo achieves privacy by encrypting the trigger price, by encrypting the tick you want the swap to trigger at, and also encrypting the order type, that is if it is a stop loss or a take profit. So where this now happens, and this is stored on the smart contract. So after this is stored in the smart contract, the order execution then happens in two phases. So when a pool swap or when a swap occurs on the pool, in the after swap hook, we trustlessly compute execution condition using FHE to perform operations on the private data imputed by the user without revealing those private data. So let me give a deeper dive into that. So basically, with fully homomorphic encryption, we are able to perform series of computation that tells us if we can execute this particular trade based on current conditions or not, without revealing any of the parameters used to calculate that computation. So after we perform this operation on the private and encrypted data, the output is an encrypted boolean that is then requested for decryption from the Phoenix coprocessor and pushed to a queue. So when another swap occurs, in the before swap hook, we check the queue to see if any encrypted results we requested for decryption is ready. If we get a decrypted value and the decrypted value is true, then we execute the swap for that particular order. That is amazing, right? So with this, we don't know the conditions that give us that particular boolean, but until it has been executed. So the contract is here in the Susanoo.so file. Then we also have tests for it here. These are the tests, and we can run forge tests to see how the test pass. Then there's also a front-end directory. We can seed into the client's directory and run npm on dev to run the UI locally. There's also a deployed version here. So this is the deployed version. As you can see, these are my order history. Then I can create a new order. Okay. So that's 10%. And I'm going to 73. So what this does is my inputs are encrypted using the Phoenix JS SDK client side before being passed into the contract. So this way, no one else has access to the values I picked on this page, apart from me myself. As you can see, my order has been successfully created. And boom, we have the other place there. You can expect CFD for our latest transaction, as you can see. So with Susanoo, we don't have to choose between transparency and privacy. Susanoo actually gives us all. Thank you.